Hi everyone, my name is Sara Papi and I will present you the paper Direct Speech Translation for Automatic Subtitling. I work with Marco Gaido, Alina Caracatà, Mauro Cettolo, Matteo Negri and Marco Turchi. And this work was published in TACL in late 2023. I will start with the question, what is a subtitle? A subtitle is a short piece of time text that is generally displayed at the bottom of the screen and that translates the dialogue or the narrative. So a subtitle is composed of two elements. The first one is the text that is shown into blocks and divided into lines. And the second one is a timestamp, that is the start and the end display times. Subtitles are stored in SRT files that are files with sequential numbers for each subtitle, the timestamps, the end and the start and the end timestamps, and the subtitle blocks. Another way of representing subtitles is the textual one, in which we lose the time information. In this case, we have two special markers. The first one is the end of block that indicates the end of a subtitle block, and the second one is the end of line that indicates the end of a line within a block. Traditional approaches to the automatic subtitling task were cascade systems. In this case, we have the audio that is used by an automatic speech recognition module to obtain the transcript of the audio. And these transcripts, together with the audio content, are given to a force aligner to obtain for each word the start and the end time. This information, together with the transcript, is given to a block segmenter and to obtain the transcript with the corresponding block levels timestamps. And the last step, the fourth one, is translating the transcript into the target language. Here, for example, from English to Spanish. However, we lose important information from the audio in the process because the audio is leveraged only by the ESR and the force aligner. So the research question here is it possible to exploit a direct ST model for producing the full subtitles, so translated text with also the corresponding timestamp? The main goal here was to investigate if and how direct ST models can be used for automatic subtitling and how they compare with the standard cascade approaches. However, current ST systems still miss the timestamp estimation to produce full subtitle. So the next question was, is it possible to exploit a direct ST model to extract timestamp information? And the answer is yes, because in this work, we introduced the first fully automatic subtitling system that leverages a direct ST model in its backbone. I will start describing the system from the direct ST model that is trained on subtitle segmented translations, or also called subtitles, with an auxiliary CDC loss on subtitle segmented transcripts, also called captions. The second step here is to retrieve the transcript timestamps using the CTC segmentation algorithm based on the CTC loss that maps the end of block present in the transcripts, in the captions, with the corresponding time frames. The last step is to obtain the translation timestamps, and this is realized by projecting the transcript's end of block with the associated timestamp into the translation end of blocks. And this is done by a timestamp projection algorithm. And we propose in the paper a Lagrange time projection, in which the projection is based on the alignment between the end of blocks that are transformed in B's and the number of characters, here T. For evaluating system, we propose to use the Mass Cinema benchmark that leverages TED Talks. And we created for the paper two new test sets covering two language pairs, English to Spanish and English to German. The first one is the European Commission or EC short videos that covers various topics with background music and multiple speakers. And the second one is Europarl interviews that contains mostly non-native speakers and highly compressed subtitles. If we move to the results, here we have an average of the results over all the test sets that I mentioned. And we measure the results using the SUBER, that is analytic metric for measuring subtitle quality that also accounts for time alignment. The performance is evaluated against a cascade architecture that is trained on the same data, but also against 5 different production tools. And since the metric subbetter, the lower the better, we can notice that the direct testing model surpasses the cascade and is even competitive with production tools. So moving to the conclusion, we propose the first automatic subtitling system that leverages a direct speech translation model. We released two new test sets for the automatic subtitling task. We also proved that direct systems outperform cascade architectures with less than with a lower sub error of about 7% on average. And we also proved that our solution is competitive with production tools. I thank you for the attention, and code and models are available on GitHub. Thank you.